This 2-hour block of Revisewise programmes is about maths. After a short introduction to the Key Stage 2 national test papers, it covers number and place value, fractions, addition, subtraction, multiplication, division, problem solving and mental maths. The starting time of each programme is shown in the menu, so they can be found by using the clock in the top right-hand corner of the screen. First, number and place value.
Hello, I'm here to help our puzzling pupil and you to make the most of what you know when you come to do your Key Stage 2 maths tests. In each of these programs, as well as in our books, audio tapes and on the internet, we'll be looking at the bits of maths you might find tricky. So, what's the problem?
I've got my maths test paper here and I'm not quite sure what to do.
Let's have a look. Aha, yes. This is just one of the 2 maths test papers that all Year 6s will be doing in May. And there's a paper A and a paper B, and in each paper there'll be questions about all the maths that you've learnt at school. Now, the people who've set these questions aren't out to trick you. They just want to know what you know. In fact, you need only get slightly more than half the questions right, and you'll get a level 4. And that's the standard everyone is hoping you'll get at the end of primary school.
You said there are 2 maths papers. What's the difference between them?
Well, both papers cover all the maths, but in the second paper, that's paper B, you can use a calculator. And in the first one, paper A, you can't. But what exactly happens on the day of the maths test?
Preparations for the test start well before the pupils arrive. The teacher has to cover any maths displays on the classroom wall. Next, the tables and chairs are moved so pupils can't see each other's work. Then she lays out all the maths equipment needed for the test.
Right, this is the equipment they need to have. Each child needs to have access to a mirror, tracing paper, an angle measurer. Some children prefer one type over another. Sharp pencil and a ruler showing centimetres and millimetres.
It's time for their first maths test. So, this Year 6 class is let into its classroom.
Right, sit down quietly, roughly where you would normally sit. Now, has everyone got all of the equipment they need for this morning?
The head teacher brings in the test papers in their sealed bags.
We're going to send around the paper. Don't open it, but on the front you can write your first name, last name, and then the school, which I've written on the blackboard for you. So take one each and then pass them on. This is paper A. You are not allowed to use a calculator, Stephen, for this paper. You are not allowed to talk to other people in the room when you're doing this test. All the work in the booklet must be your own work, so you're not allowed to copy someone else's work. Does everyone understand that? It must be your work. Baby paper. For this paper, you will have 45 minutes. Right, you may open to the question 1 and begin.
Once the test starts, It's all down to them.
So, is that it then?
Not quite. There's also a short mental maths test. So what's all that about?
Here is the practice question to show you what to do. What is 6?
In the mental maths test, you listen to the questions played from a tape.
What is 6 less than 25?
You work out the answers in your head and write them down on the paper.
Question 1. How many 20p pieces are there in £2?
The finished test papers aren't marked by your teachers. They're sent off to be marked by other teachers who don't know you or your school.
So, there they are.
The people marking the tests add up all the marks from your 3 papers. Paper A, Paper B, and your mental maths. And that's what gives you your level, level 4, we hope. So if you don't do well on one paper, you could do better on another and still get your level 4. Of course, how you get on in your test is up to you. But one thing is certain. If you've prepared well, then you'll do well. And that's what we're here to help you with.
I've got my pencil, my ruler, my angle measure, my mirror, and my tracing paper. I'm ready to get stuck in.
No, don't just dive in straight away. You've got 45 minutes, that's 3/4 of an hour for each paper. So there's plenty of time to read all the questions first and check the answers. So let's look inside a real test paper. In each paper there are about 20 questions. They start with the easier ones first, and they get more difficult as you go on. Now, some things you can do in your head, and some things you'll need to write down. One thing worth knowing is that all the questions on the different parts of maths you've done at school are mixed up throughout the paper. Here's one on number work. Here's one on recognizing shapes. And here's one on graphs and charts. Allow between 1 and 2 minutes for each question. And if you get stuck on a question you can't do straight away, it's worth going on to the next one, because it might be about something completely different that you can do. So, let's make a start with some real maths test questions.
Use all the digits 6, 1 and 3 to write a number that is between 100 and 140.
Now that's a good question to start. It's about the number system. But before we have a go at it, let's remind ourselves what we know about number and place value. Over to our maths team.
Units,
Tens,
hundreds,
thousands, 10,000s,
100,000s, millions.
All these digits are the same. They're all 2s. But they mean something different depending what place they're in. When it's there, it means 2. When it's there, it means 20. There, 200. 2,000, 20,000, 200,000, and 2 million. Watch how these numbers get bigger and bigger. What do we call a big number like this? Over to our maths team.
This number is 868. It's made up of 800s, 60 and 8.
So what's this big number called?
This number is 26,243. It's made of 26,200s, 4 tens and 3 units.
So let's go back to your test question.
Use all the digits 6, 1 and 3 to make a number between 100 and 140. With those digits, I can make 613, but that's too big to be between 100 and 140, so is 631. I can make 361 and 316, but they're too big as well. So that leaves 163, that's too big, and 136, which is between 100 and 140.
Well done. So put it in the box. Now, what happens when you multiply a number by 10?
This number is 32. It is made up of 3 tens and 2 units. When it is multiplied by 10, the 2 digits move 1 place to the left, and where the 2 units were, a 0 fills their place.
So, when you multiply a number by 10, the digits move 1 place to the left, and you put a 0 in the space. And when you multiply a number by 100, the digits move 2 places to the left, and you put 2 zeros in the space. And when you multiply a number by 1,000, the digits move 3 places to the left, and you put 3 zeros in the space. And multiplying by 1,000 is equivalent to multiplying by 10, and then by 10 again, and then by 10 again. When you divide a number by 10, the digits move 1 place to the right. And when you divide a number by 100, the digits move 2 places to the right. And when you divide a number by 1,000, the digits move 3 places to the right. This works exactly the same way with decimal numbers. When you multiply by 10, the digits move 1 place to the left. When you divide by 10, the digits move 1 place to the right. The decimal point stays where it is. How can we use what we know about place value to sort big numbers into order, like these two? Over to our maths team.
To see which is the biggest number, first you look at the thousands, then the hundreds, then the tens, then the units. But on this one has 7 thousands each, 2 hundreds each, and this one has 6 tens, and that one has only 1, so it makes this one the biggest.
Let's try another one, this time with some decimal numbers. Put these numbers in order. At a glance, the 985 may appear bigger than the 463, but look carefully at their place value and where the decimal point is. It's a good idea to write the numbers underneath each other, and even to write in the missing zeros as well. Then you can see that 463 has 4 hundreds and the others have no hundreds, so 463 must be the largest number. 78.3 has 7 tens and the others have none, so 78.3 is the next largest. 8.35 has 8 units, while 0.985 has none, so 8.35 is the next largest. And 0.985 is the smallest. That's the end of our unit on number and place value. So let's check what we've done. We saw what happens on the day of the maths test. We looked at the number system and place value. We saw what happens when you multiply and divide numbers by 10. And we worked out what big numbers are called and how to put them in order. You and your friends and family can always go over these things at home. And don't forget, you can wind the tape back and look at bits of the program again. There are also books and our interactive Revisewise website to help you make the most of what you know when you're preparing for your test. So we'll let you get on with your test and you get on with your television revision.
The next program is about fractions.
Hello, I'm here to help you and our puzzling pupil make the most of what you know when you do your Key Stage 2 maths tests. In each of these programs and in our books, audio tapes and on the internet, we're looking at the maths you might find tricky. This time, it's fractions. So, what's the problem?
I'm a bit stuck on this question.
Well, let's hear it then.
Draw one line to join two fractions which have the same value.
Fractions are something we can all have trouble with. So what does our maths team have to say about them?
This is 1/3. A whole has been split into 3 equal parts. You have one of those equal parts. This is 1/8. A whole has been split into 8 equal parts. You have one of those 8 equal parts. This is 1/20. A whole has been split into 20 equal parts. You have one of those 20 equal parts.
1/3 of a pizza means that one whole pizza has been split into 3 equal parts. And we have one of them. 1/8 of a pizza means that one whole pizza has been split into 8 equal parts. And we have one of them. 1/20 of a pizza means that one whole pizza has been split into 20 equal parts. And we have one of them.
The bottom number of a fraction is called the denominator. It tells you how many equal parts the whole has been split into.
To put these fractions in order, you have to look at the denominator. The bigger the denominator, the smaller the fraction would be. So 1/20 is the smallest fraction.
Now that's a really useful thing to remember. The bigger the denominator, that's the number on the bottom, the smaller the fraction. 1/3 of a pizza is a big chunk because there are only 3 of them in the whole pizza. 1/20 of a pizza is only a small slice because there are 20 of them in the whole pizza. The top number of a fraction is called the numerator, and it tells you how many equal parts of the whole have been taken. So, for example, 2/3 means that the whole has been split into 3 equal parts, and we have 2 of those parts. More from the maths team.
These are the denominators. They show you how many equal parts a whole has been split into. These are the numerators. They show you how many of those equal parts you have.
Some fractions look different, but are worth the same. They have the same value. They're called equivalent fractions. The maths team explains.
Fractions can be equivalent. Like 1/4 is the same as 2/8. And 1/4 is also equivalent to 4/16.
Look at these equivalent fractions. 2/3 is equivalent to 4/6, and it's also equivalent to 6/9 and 8/12. See if you can spot the equivalent fractions before Mathman does.
Mathman, your mission is to eat only fractions equal to 1/3. When you come to a number, you will have until a count of 3 to make your decision. And beware the obstreperous Mr. Glitch. He will eat you if you are wrong.
Yep. Mathman, 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 Mathman. Yep. 1/3. I still got it. Mathman, 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 Mathman. That's 1/3.
Where is no?
Right again. Mathman, Mathman, 1/3, 1/3. Mathman, 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 Mathman. Use your head. Nope. Mathman, 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 Mathman. Mathman, Mathman.
How can we check if two fractions are equivalent? One way is to multiply the numerator and denominator of one fraction by the same number and see if you get the other fraction. Let's see if it works. Is 3/4 equivalent to 6/8? The denominator of 3/4 is 4. Multiply it by 2 and the denominator becomes 8. The numerator of 3/4 is 3. Multiply it by 2 as well, and the numerator becomes 6. So 3/4 is equivalent to 6/8. There's another way you can check if fractions are equivalent. You can divide the numerator and denominator of one of the fractions by the same number and see if you get the other fraction. Is 12/16 equivalent to 6/8? The denominator of 12/16 is 16. Divide it by 2 and the denominator becomes 8. The numerator of 12/16 is 12. Divide it by 2 as well and the numerator becomes 6. So 12/16 is equivalent to 6/8. Dividing the numerator and denominator by the same number like this to make them as small as you can is called simplifying a fraction. Let's simplify 12/16. What number can we divide both the numerator and the denominator by? Try 2. 2 into 12 is 6, and 2 into 16 is 8. So 12/16 simplifies to 6/8. Can we simplify further than this? Try 2 again. 2 into 6 is 3, and 2 into 8 is 4. So 12/16 simplifies to 3/4. And that's as far as we can go. Now, does that help you answer the question?
Well, let's see. They're all different fractions, but the question says I've got to look for two fractions that have the same value. So, am I looking for two equivalent fractions?
That's right.
So I'm looking for a fraction that I can simplify by dividing the numerator and the denominator by the same number.
Yeah, go on.
Well, let's see. It's 2/8.
Yeah, but why?
Because I can divide both the numerator and the denominator by 2. 2 into 8 is 4, and 2 into 2 is 1. So 2/8 becomes 1/4. So that's the answer.
Yeah, now is it? What exactly does the question ask you?
Draw one line to join two fractions which have the same value. Oh, I see. I have to draw a line from the 2/8 to a 1/4, like this. Like so.
Exactly. It's really important, once you've done the maths, to check the question again to be sure you've actually answered what it asked you.
Here's another question about fractions. It says, place these fractions in order of size, starting with the smallest. Then it's got 1/2, 1/3, 5/12, and 5/6.
It's an interesting question. Go on, have a go.
Now I know that 1/3 is smaller than 1/2.
Why?
Because there are more thirds in a whole than there are halves. So they must be smaller.
And something else that we learned?
Oh yes, the bigger the denominator, the smaller the fraction. But it's hard to tell about the others. They're all different fractions.
I think equivalent fractions are going to help here.
I've got it. What if I change each fraction so they all have the same denominator? Then I can compare them properly.
You're on the right track. So what denominator could you change all these fractions to? And remember, it must be the same denominator for all the fractions.
How about 12ths?
Try it.
Right. With the 1/2, I have to multiply the denominator by 6 to get 12ths. So I multiply the numerator by 6 to get 6/12ths. With the 1/3, I multiply the denominator by 4 to get 12ths. So I multiply the numerator by 4 to get 4/12ths. The 5/12ths is already a 12th, so I can leave it alone. With the 5/6, I multiply the denominator by 2 to get 12ths. I multiply the numerator by 2 to get 10/12ths. So that's it. The smallest is 4/12ths, the next is 5/12ths, the next is 6/12ths, and the biggest is 10/12ths. Done it!
But have you? Once you've done the maths, check what the question is asking.
Oh, I have to write the original fractions in the boxes, like this.
Yes, that was a close thing, and after all that work, so it really is important to read the question. Another kind of question you might get is to find the fraction of another number, or a length, or a quantity of money. Like, what's 3/4 of 24 centimetres? First of all, divide the 24 centimetres by the denominator to find 1/4 of 24 centimetres. 24 centimetres divided by 4, that's 6 centimetres. Then multiply the answer by the numerator, that's 3. 6 centimetres times 3 is 18 centimetres. So 3/4 of 24 centimetres is 18 centimetres. So to find the fraction of a quantity, divide by the denominator and then multiply by the numerator. Finally, fractions can also be written as their equivalent decimal. That's the decimal number that has the same value as the fraction. Over to our maths team.
1/2 is equivalent to 0.5.
1/4 is equivalent to 0.25.
3/4 is equivalent to 0.75.
1/10 is equivalent to 0.1.
2/10 is equivalent to 0.2.
3/10 is equivalent to 0.3.
See if you can spot all the numbers less than 1/2 before Mathman does.
Mathman, 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 Mathman. That's less. Too smart. Mathman, 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 less than 0.5. Mathman, 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 Mathman. That's less too. Yeah! Less than 0.5. Mathman, 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 Mathman. Wow. Must be less. Rats.
That's the end of our unit on fractions. So what did we learn? We saw that fractions are parts of a whole, We looked at equivalent fractions and how to simplify fractions. We put fractions in order and we looked at the decimal equivalents of fractions. You and your friends and family can always go over these things at home. And don't forget, you can wind the tape back and look at bits of the program again. There are also books and our interactive Revisewise website to help you prepare.
The next program is about addition.
In these programs and in our books, audio tapes and website, we're helping you with the things you might find tricky in your Key Stage 2 maths tests. This time, it's addition. Let's start with a real test question.
In the chart, any three numbers in a line, across or down, have a total of 18.45. Write the missing number. And then there are all these numbers in the square. I guess I have to add them up somehow.
You're right, but I think to get this one right, you're going to have to do several different things. Most of the questions on the test paper need a mixture of different math skills. For example, there might be a bit of adding and then a bit of multiplying. Or you might have to look something up on a graph and then do something with the numbers. But in this question, you definitely have to add up some numbers. Adding up numbers is something we do in maths all the time. So let's remind ourselves exactly what it means. Over to our maths team.
Addition means how many altogether.
It also means increase.
It also means plus.
It also means total. It also means sum. It also means more than.
And in everyday life, adding numbers is all around us.
When you go shopping and buy a couple of things, you can add the prices up in your head.
Mine's 49p.
Mine's 55p.
And that makes
£1.4p.
This is 69p. And this is 55p.
When you buy more things, you can write the prices down to add them up.
One. That's a 4. That makes £3.41p.
That's 69 pence.
Another way to add up lots of things is to use a calculator.
That's 79 pence. That's 341 please.
Now, when you're faced with some numbers you want to add up, it's useful to think first, can I do it in my head? Do I need to write it down? Or should I use a calculator? First, some addition sums in your head, some mental addition. How about 59 plus 43? See if you can do it before our maths team does.
To find the answer to 59 at 43, I'd turn the 59 to a 60, then at the end take away 1, and the answer would be 102.
To find the answer to 43 at 59, I'd add 40 at 50, then 3 at 9, and then add the totals together, which will make 102.
Did you notice that Nicola did 59 plus 43 and Sarah did 43 plus 59? But with addition, it doesn't matter which order you do it in. Also, they use different methods to help them get the right answer. Each time, they changed the sum into something that was easier to work out on the way to getting the right answer. Let's look again at what Nicola did.
To find the answer to 59 at 43, I'd turn the 59 to a 60, then at the end take away 1, and the answer would be 102.
What she did was to add 1 to the 59 to round it up to 60. It's easier to add 43 to 60 to make 103, then take the 1 off again to get the right answer, 102. With any number ending in 9, you can add 1 to make the sum easier. With a number ending in 8, add 2 to make the sum easier. And with a number ending in 7, add 3 to make the sum easier. Let's look at the other method that Sarah used.
To find the answer to 43 at 59, I'd add 40 at 50, then 3 at 9, and then add the totals together, which will make 102.
What she did was to split the numbers up and add the 10 separately from the units. 43 and 59 is the same as 40 and 3 and 50 and 9. 50 plus 40 is 90, and 9 plus 3 is 12. Add the two together to get 102. You can practice adding up two-digit numbers in your head. It's something you can do with your friends or at home, like this.
83 plus 19.
$102. 42 plus 18.
60. 17 plus 37.
54.
Does this help you with your question?
I'm not sure I can do the adding up in my head, so could I write it down alongside here?
Good idea. When the numbers you want to add up get larger or more difficult, it might be better to use a written method, particularly if the numbers have decimals in them. Over to the maths team.
Stuart's adding 421.36 and 25.7. See how careful he is to make sure he lines up the units under each other, gets the tens under each other, and the hundreds under each other, and lines up the decimal points.
Here's a useful tip when you're doing a written addition. Before you start doing the maths, make an estimate of what you think the answer should be. Try 3.85 plus 16.8. 3.85 is nearly 4, and 16.8 is nearly 17. So the answer is roughly 4 plus 17, and that's 21. Let's see if it is, and watch out in case I make a mistake. 8 and 5 is 13. Put down 3 and carry 1. 8, 6 and 1 is 15. Put down 5 and carry 1. 3, 1 and 1 is 5, so that's 55.3. That can't be right. My estimate was just less than 21. What's gone wrong? I didn't line up the decimal points properly, so my place values were all over the place. I was adding tenths to hundredths and tens to units. That's better. Let's try it again. 5 and 0 is 5. 8 and 8 is 16. Put down the 6 and carry 1. 6 and 3 and 1 is 10. Put down the 0 and carry 1. 1 and 1 is 2. That's 20.65, and that is close to my estimate of 21. So I'm sure it's the right answer.
I think I'm ready to have a go at this question now.
And where you go then?
Right. I've got to find the missing number in the middle of the square. Now, the question tells me that each line in the square must add up to 18.45.
That's right.
If I take the row across the middle, I need to add up the numbers I've got and then take them away from 18.45. So that's 11.07 plus 1.23, which equals 12.30.
Yes, go on.
And I take that away from 18.45 to get 6.15.
And how about checking that answer?
Oh yes, I can add up the line of numbers down the middle of the square to see if they come to 18.45 as well. Let's see. 8.61 plus 3.69 plus 6.15 equals 18.45. So my answer must be right.
There's a third way of adding up numbers, besides doing it in your head or writing it down, and that's to use a calculator. Using a calculator seems really easy. Because it's electronic, it's tempting to think that whatever answer it gives, it must be right. Wrong. The answer a calculator gives you depends on what you tell it when you press the keys. If you tell it the wrong thing, by pressing the wrong keys, for example, it will tell you the wrong thing. So make an estimate first. Let's try 2,593 plus 6,078. Make an estimate first. It's a bit more than 2,500 plus 6,000, which is 8,500. Now we can see what the calculator comes up with. First, press the clear key to get rid of any calculations that might be in the calculator already. Then press 2593 plus 6078 equals 8,671, which is close to my estimate of 8,500. The calculator will always give you an answer, but only you can decide if it's right. Take adding money, for example. £3.55 plus £4.75. That's 3.55 plus 4.75 equals 8.3. But is that really the right answer? If it were just numbers, it would be, but it's money, pounds and pence. So we have to write it as 8.30 or £8.30.
Here's a question in the test about adding money. They give you a pizza menu and ask, Jill orders one small cheese pizza with extra tomato. What is the total cost?
Yeah, that's a good one. Let's do it.
Well, I look up the price of a small cheese pizza in the table, which is £3.80, and the extra tomato is 50p. So that's 3.80 plus 0.5, which is 4.30.
Now, is that right? The maths is right, but the question is about money. So what's missing?
Oh, I've missed out the pound sign.
There are lots of questions in the maths papers about money and lengths and weights. So it's important to read the question properly and check that you've given the answer in the right units. And what about the second part of the question for an extra mark?
Ben buys one small pizza and one medium pizza. They cost him £10. Which two could they be?
More addition.
So I'm looking for an amount in the small column and an amount in the medium column that add up to 10. Right, it's £4.50 and £5.50. That's a small mushroom and a medium ham. So I better write that in.
There are often questions like this, where the answer is a word or a sentence instead of a number.
That's the end of our program on addition. So let's check what we've done. We looked at ways of doing mental addition in our heads and saw how to write down more difficult addition. We saw how to use a calculator to do addition and looked at real-life problems that involve addition. You and your friends and family can always go over these things at home. And don't forget, you can wind the tape back and look at bits of the program again. There are also books and our interactive Revisewise website to help you prepare.
The next program is about subtraction.
To help you with your Key Stage 2 maths tests, in this unit we're going to look at subtraction.
I'm a bit stuck on this question. It says 60 minus something equals 26.
Subtraction. Subtraction is something we do a lot in maths, so let's remind ourselves what it means. Over to our maths team.
Subtract means take away. It also means decrease. It also means difference between.
It also means minus.
It also means less than.
It also means count back.
In everyday life, taking away numbers is all around us.
You use subtraction to work out the right change.
These are 55p. How much change would we get from your pound? It would be 45p.
When you're faced with numbers you want to take away, it's useful to think, can I do it in my head? Do I need to write it down? Or should I use a calculator? First, some subtraction sums in our head, some mental subtraction. 54 subtract 37. See if you can do it before our maths team does.
To work out the answer for 54 subtract 37, I rounded the 37 to 40 and took it away, which was 14. Then I added on the 3, which gave the answer 17.
To get the answer from 54, take away 37. I split the 37 into 7 and 30. I took away the 7 from 54, which I got as 47, and I took away the 30 and I got 17 as my answer.
Although they use different methods to help them get the right answers, they both changed the sum into something easier that they could work out first. Let's look again at what Nicola did.
To work out the answer for 54 subtract 37, I rounded the 37 to 40 and took it away, which was 14. Then I added on the 3, which gave the answer 17.
What she did was to count up in steps from 37 to 54. The first step was from 37 to 40, the nearest 10. That step is 3, which she held in her head. The next step was from 40 to 50, which is 10. And then 50 to 54, which is 4. Adding the steps together gives the answer, 17. While she was doing her subtraction, Nicola was actually doing bits of addition. In fact, addition and subtraction are related, and you can often use addition to help you work out a subtraction. For example, we can check 54 take away 37 equals 17 by adding 37 to the 17 and getting 54 again.
Here are 54 blocks. Take away 37 and you're left with 17. Add the 17 to the 37 and you get 54 again. You can see how addition and subtraction are related if you think about what happens when you buy something and get some change. The shopkeeper subtracts the price of what you buy from the money you give him, and the answer is the change he gives you. So your change is the difference between what you paid and the price of the sweets. What you pay is the sum of the price of the sweets and your change. The price of the sweets is the difference between what you pay and your change.
So how does all this help you answer the question?
Well, they want the number you can take away from 60 that makes 26. I can turn that into 60 equals 26 plus something. Should I use a number line?
Good idea.
That's right. Draw out the number line first and put your numbers on it.
From 26 up to 30 is 4, and from 30 to 60 is 30. So that's 34 altogether.
So write it in the box. Practice subtracting numbers in your head. It's something you can do with your friends or at home.
63 minus 19.
Hmm. 44. 54 minus 11.
43. 100 minus 64.
36.
When the numbers you want to subtract become larger, it's a good idea to draw out a number line for yourself and jot down the steps you've taken along it. Let's try 217 minus 136. The step from 136 to the nearest 10, 140, is 4. The step from 140 to the next nearest 100, 200, is 60. And the final step from 200 to 217 is 17. Add all the steps up together, and the answer is 81. So 217 minus 136 equals 81.
Here's another subtraction question with bigger numbers. Calculate 808 minus 512.
So how are you going to do it?
I could count up from 512 to 808 in my head, or along a number line, but it looks a bit too difficult for that.
You're right. If the numbers have several digits or decimals in them, you'd be better off using a written method. How about 19.27 minus 8.4? First thing to do is make an estimate of what the answer might be. Let's round 19.27 down to 19 and 8.4 down to 8. 19 take away 8 is 11, so that's my estimate. Now back to the proper sum. Write it out in columns with the tens, units and decimals lined up properly underneath each other. 0 from 7 is 7. 4 from 12 is 8. 8 from 8 is 0, and 0 from 1 is 1. So the answer is 10.87. And that's pretty close to my estimate of 11, so my answer's probably right. Now you can try to answer your question.
Okay. Calculate 808 minus 512. So I make an estimate first. 808 is just over 800, and 512 is just over 500. So the answer should be around 800 take away 500, which is 300.
Okay, now do it.
Right. So I write the numbers above each other in lined columns. the units first. 2 from 8 is 6. The tens. 1 from 10 is 9. And then the hundreds. 5 from 7 is 2. So the answer is 296. That's very close to my estimate of 300, so it must be right.
So write it in the box. Now let's not forget the third way of subtracting numbers, and that's using a calculator. Because it's electronic, it's tempting to think that whatever answer a calculator gives, it must be right. Wrong. It depends on what you tell it when you press the keys. If you make a mistake and tell it the wrong thing, it will tell you the wrong thing. Let's try 2,615 minus 1,997. Make an estimate first. That's about 2,600 minus 2,000. Which is 600. What does the calculator come up with? Press the clear key to get rid of any previous calculations. Then 2615 minus 1997 equals 618, which is close to my estimate of 600.
Here's a question or test about subtracting money. They give you the cost of different rides at a fun fair, and you have to work out which ride John could go on and get 80p change from £2.
Right, let's do it.
Well, I have to work out the difference between the money that John's got and the change he'll get back. That's the difference between £2 and 80p. That's £1.20.
Well, the maths is right, but what does the question ask?
It asks which ride John went on, so I have to look up the one that cost £1.20. That's the big wheel.
So, write it down. That's it for subtraction. So let's check what we've done. We looked at quick ways of doing subtraction in our heads and how to write down more difficult subtraction. We saw how to use a calculator to do subtraction, and we looked at some problems involving subtraction. You and your friends and family can always go over these things at home. And don't forget, you can wind the tape back and look at bits of the program again. There are also books and our interactive Revisewise website to help you make the most of what you know when you're preparing for your test. So we'll let you get on with your test and you get on with your television revision.
The next program is about multiplication.
In this unit, we're looking at multiplication to help you make the most of what you know when you come to do your Key Stage 2 maths tests.
What's the best way to work this question out? It says, calculate 58 times 6.
That's multiplication, all right. Multiplying numbers is something we do a lot in maths, so over to our maths team to remind us what it means.
Multiply is the same as times.
It also means product.
It also means lots of.
It also means groups of.
It also means sets of.
And it also means repeated addition.
In everyday life, we're often multiplying numbers.
When you buy a few of the same thing, you can do the multiplication in your head.
They're 35p each, so how much are 3? Well, 35 times 3 is 105, so that must mean they're £1.5. So those are 6 bottles, which are all 39p, so 39 times 6.
When you buy more of the same thing, write the prices down to multiply them.
£2.34.
246 times 39.
Another way to multiply the price of several things is to use a calculator.
It's 234.
Now, when you're faced with some numbers you want to multiply, it's useful to think first, can I do it in my head? Do I need to write it down? Or should I use a calculator? Let's look at how to do multiplication in our head. That's mental multiplication. The secret is to know your multiplication number facts, otherwise known as your times tables.
1 times 4 is 4, 2 times 4 is 8.
3 times 5 is 15. 4 times 5 is 20.
6 times 6 is 36. 7 times 8 is 56. 9 times 9 is 81. And 10 times 9 is 90.
Once you're sure about your tables, you can use them to help with any multiplication problem. Have a look at this one. What's 40 times 70? Well, we know from our times tables that 4 times 7 is 28. 4 times 70 is going to be 10 times bigger. So that's 280. 40 times 70 is going to be another 10 times bigger. That's 2,800. The trick is to multiply the significant digits and then make sure you get the place value right by having the same number of zeros in your answer. Try this one. 400 times 700. 4 times 7 is 28, and there are 4 zeros. So we need 4 zeros in the answer, turning the 28 into 280,000. Let's get our maths team to have a go at the question. 58 times 6. Can you do it before they do?
This is how I would work out 58 times 6. I'd do 50 times 6 is 300, then 8 times 6 is 48, and add it together, which would equal 348.
This is how I would work out 58 times 6. I would do 10 times 58, which was 580. Then I would half that to 290. Then I'd do 1 times 58, and then I'd add them together for 348.
Although they use different methods to get the right answer, they both changed the sum into something easier that they could work out first. So that should help you answer your question.
It certainly does. I split the 58 into 50 and 8. 50 times 6 is 300, and 8 times 6 is 48. So I add them together to get 348.
That's right. Whichever way you use, it's really worth practicing mental multiplication with friends or at home.
7 times 9.
63. 60 times 4.
240. 800 times 6.
4,800.
Here's another multiplication question, but it's got a digit missing.
Missing digit questions like this often come up in tests, and they can seem tricky to work out. Just keep your wits about you and use what you know to get the answer. Try this one. 50-something times 8 equals 456. Let's ignore the missing digit for now and do 50 times 8, which is 400. That leaves us 56 short of the right answer, so we look for something that multiplies by 8 to give 56. Seven times 8 is 56, so the missing digit is 7.
OK, so I ignore the missing digit for now and do 7 times 9, which is 63. But that leaves me 270 short of the right answer, so I look for something to multiply by 9 to give 270. Thirty times 9 is 270, so the missing digit is 3.
So write it in the box.
What about this question? It looks a bit harder. I'm not sure I can do it in my head.
OK. When the multiplication is too difficult to calculate in your head, use written methods, like our maths team.
This is how I would work out 738 times 46. I would break up the 46 to 738 times 20, which would equal 14,760. Then I do 738 times 20 again, which equaled the same answer. So that was 40 times. Then I do 738 times 3, which equals 2,214. Then I do 738 times 3 again, which equaled the same. So that was 46 altogether. Then I'd add up all these answers. 40. And the answer would be 33,948.
Here's another method.
This sum is 738 times 46. I'm splitting up the numbers so that it still makes the same number. 40 times 700, but I'm going to take away the zeros, which equals 28, and add on 3 zeros. Then I'm going to do 40 times 30, which equals 1,200. Then I'm going to do 40 times 8, which is 320. Add those all together and it equals 29,520. I'm going to do 6 times 700, which equals 4,200. 6 times 30 equals 180. 6 times 8 equals 48. Add those all together and it equals 4,428. Add those all together and it equals the answer is 33,948.
With a big sum like this, there are lots of chances of making a mistake, so it's a good idea to make an estimate of roughly what the answer ought to be. So does that help answer your question?
Yes, I'll write the sum out.
But don't forget to do an estimate first.
Ah, yes. How about turning 431 times 23 into 400 times 25. 4 times 25 is 100, with 2 more zeros. That makes 10,000.
OK, so now do the sum.
431 times 3 is 1,293. 431 times 20 is 8,620, and you add them up, to get 9,913.
And how does that match your estimate?
Well, 9,913 is pretty close to 10,000, so I'd say my answer is probably right.
Don't forget the third way of multiplying numbers, using a calculator. It's tempting to think that because they're electronic, they're always right. Wrong. The answer a calculator gives depends on what you tell it when you press the keys.
Here's a question that looks as though it's about multiplication, and it's on paper B, so I can use the calculator to do it.
Go on then.
2,753 people go to a sports event. Each person pays £2.30 for a ticket. What is the total amount of ticket money collected?
That's a good one. There are lots of questions about real-life situations like this on the test papers. The first thing to work out is what maths to use.
So I multiply 2,753 by 2.30, and it equals 6,331.9. So that's the answer.
Now, is it? Remember the trap you can fall into when working out money calculations on a calculator?
Ah, of course. The answer should be in pounds and pence. So I have to write £6,331 90p.
That's right. Well, that's the end of our unit on multiplication. So let's check what we've done. We did some mental multiplication using known number facts to help us. We looked at ways of doing written multiplication with bigger numbers and saw how important it was to estimate the answer first. We used a calculator to multiply. And we looked at some real-life multiplication problems. You and your friends and family can always go over these things at home. And don't forget, you can wind the tape back and look at bits of the programme again. There are also books and our interactive Revisewise website to help you prepare.
The next programme is about division.
In this programme, to help you with your Key Stage 2 maths tests, we're going to take a look at division. Now, can you see any questions about division in your test paper?
Yes, here's one. It says, 2 of these numbers divide by 5 with no remainder. Circle the 2 numbers.
That's a good one to start with, and it shows what a close link there is between division and multiplication. If you know your multiplication tables, then you can do division as well. Back to your question, are any of these numbers in the 5 times table?
Let's see. 5 times 5 equals 25, and 5 times 12 equals 60.
That's right. It's really useful to know your divisibility rules. That's things like a number is divisible by 5 if it ends in 5 or 0. And the maths team have got some more examples.
A number is divisible by 10 if it ends in a naught.
A number is divisible by 2 if the last digit is even. A number is divisible by 3 if the sum of all the digits is divisible by 3.
A number is divisible by 9 if the sum of all the digits is divisible by 9.
When we talk about division, there are lots of different ways of saying it. So, back to the maths team.
Division means share equally. It also means group equally.
It also means divide by.
It also means repeated subtraction.
When you're faced with numbers you want to divide, it's useful to think first. Can I do it in my head? Do I need to write it down? Or should I use a calculator?
Here's another division question. This time it's got a missing number. It says something divided by 5 equals 22.
And I think you can do this one in your head. With division like this, you can use what you know about multiplication to work out the answer. We're looking for something divided by 5 that gives us 22. Well, there's a big something. Divided into 5 parts, and each of them is worth 22. So the something we're looking for equals 22 plus 22 plus 22 plus 22 plus 22. That's 5 times 22 equals 110. So 110 divided by 5 equals 22.
So I'll write 110 in the box.
See how multiplication and division are related to each other. 5 times 22 equals 110. 110 divided by 5 equals 22. And 110 divided by 22 equals 5. Once the numbers get bigger, it gets too difficult to do the division in your head, and you'll have to write it down. Let's try a difficult one, like 972 divided by 36. And with something like this, it's important to make an estimate first of roughly what the answer should be. See if the maths team can do it.
This is how I would work out 972 divided by 36. First I would make an estimate, and that I would make 972 to 1,000, make 36 to 40, and 1,000 divided by 40 is 25. So then I would do 36 times 10 equals 360. Then 36 times 10 again, which equals the same. Then I would try 36 times 5, which is half of 10 times, so that would be 180. Then altogether, these 3 answers add up to 900, so there's 72 left, which would be 36 times 2 equals 72. So altogether, that equals, which equals 27, so my estimate was about right.
See how Nicola made an estimate first, rounding the 972 up to 1,000 and the 36 up to 40. Then she did 1,000 divided by 40 to get her rough estimate of 25. Then she broke this difficult problem down into easier sections. Nicola knew that 36 times 10 is 360. Take that away from the 972 to get 612. 36 times 10 again is another 360. Take that away from the 612 to get 252. Next, she did 36 times 5, which she knew is half of 36 times 10, and that's 180. Take 180 from the 252 to get 72. And Nicola knew that 72 is 36 times 2. So altogether, she got 27 36s. So the answer to how many 36s in 972 is 27, which is close to the estimate of 25. Let's try something a bit easier. 972 divided by 6. We'll go through it carefully, step at a time. The nearest number of times that 6 will go into 9 is 1. 1 times 6 is 6. 6 from 9 is 3, bring down the 72. The nearest number of 6's into 37 is 6. 6 times 6 is 36. 36 from 37 is 1, bring down the 2. 6's into 12 is 2. 2 times 6 is 12. 12 from 12 is 0. So the answer is exactly 162. The important thing is to make sure everything is lined up properly, with the units above each other, the tens above each other, and so on. If one number divides into another exactly, the answer comes out as a nice whole number. But what do you do if something doesn't divide exactly? Well, there are 3 ways you can give the answer. With a whole number remainder left over, as a fraction, or as a decimal. And let's have a go at 46 divided by 5 each of these ways. You can have a go at this.
Well, I know that 45 divided by 5 is 9, so 46 divided by 5 is 9 remainder 1.
That's right. Let's see what the answer is as a fraction. There's another way of looking at the remainder 1 left over, and that's to ask 1 what left over. And because you're dividing by 5, this remainder left over is 1/5. So 46 divided by 5 is 9 and 1/5. What's the answer as a decimal? 46 divided by 5. Well, the nearest 5 into 46 is 9. 9 times 5 is 45. 45 from 46 is 1. Add a 0 after the decimal point so we can carry on and bring it down. 5 into 1.0 is 0.2. 0.2 times 5 is 1. 1 from 1 is 0, so that's it. 46 divided by 5 is 9.2. So 46 divided by 5 is either 9 remainder 1, 9 and 1/5, or 9.2. In the test, you'll often get questions about real-life situations, testing if you can work out what to do with the remainder of a division sum. Try this. A cinema ticket costs £5. How many tickets can I buy for £46?
That's easy. You just divide 46 by 5.
Well, that's right, but then what do you get?
9.2, or 9 and 1/5.
Those are answers to 46 divided by 5, but you can't buy 0.2 of a ticket or 1/5 of a ticket. Let the maths team have a go.
First I do 46 divided by 5, which equals 9 remainder 1. I have to round that down to 9 because I haven't got enough money to buy another ticket.
So Keely had to round the answer down for it to make sense. She couldn't buy a fraction of a ticket, so she had to settle for 9 tickets and have £1 left over. Now try this question. There are 46 children in the dining hall. Each table seats 5. How many tables do I need to seat all the children?
That's 46 divided by 5 again.
Well, that's right. So, back to the maths team.
First you would do 46 divided by 5, which will be 9 remainder 1. You would need 9 tables, but then you need to round up to 10 tables for that one child left over, so altogether you would need 10 tables.
So Nicola had to round the answer up for it to make sense. She couldn't sit a fraction of a child at each table, so the one child left over needed a whole table to sit at. With division problems like these, you have to check exactly what the question is asking you and then give an answer that makes sense.
Here's one in this test paper. It says there are 70 children camping. Each tent takes up to 6 children. What is the least number of tents they will need?
Off you go then.
Well, I need to divide the total number of children by the number of children each tent can hold, and that will give me the number of tents.
Yes.
That's 70 divided by 6. 11 times 6 equals 66. So the answer is 11 remainder 4.
But what do you do with the remainder?
Well, the remainder is 4 children, and they need a whole tent. So I have to round the answer up to 12.
So write the answer in the box for 2 marks. Don't forget to show your workings out in the box. If you get an answer wrong, but your working is right, you'll get a mark. Now the third way of dividing numbers, using a calculator. Don't forget, the answer a calculator gives you depends on what you tell it when you press the keys. So it's really important to do an estimate first to check the calculator's answer.
My sum is £332 divided by 8. I'll divide my £332 to £320 divided by 8, which would be about 40. Now I'd make sure my calculator is clear, and I'd have to type in 332 divided by 8 and equals, which is 41.5. But because it's money, I'd have to say it's £41.50.
So whatever your calculator gives, when you're doing a money problem, always give the answer to 2 decimal places to get the number of pence right. That's the end of our program on division. So let's check what we've done. We did some mental division using what we know about multiplication to help us out. We looked at ways of doing written division with bigger numbers and saw how important it was to estimate the answer first. We looked at some real-life division problems where you have to work out what to do with the remainder. And we used a calculator to do division, being careful to make sense of the answers it gave us. You and your friends and family can always go over these things at home. And don't forget, you can wind the tape back and look at bits of the program again. There are also books and our interactive Revisewise website to help you prepare.
The next program is about problem solving.
Hello, I'm here to help you and our puzzling pupil make the most of what you know when you come to do your Key Stage 2 maths tests in May. In each of these programs and in our books, audio tapes and on the internet, we're looking at the maths you might find tricky. Now this time, it's problem solving. What do we mean by problem solving? Often the maths questions we get asked are just numbers on the page, like this. £2.20 multiplied by 6 equals... Go on, you try it.
Well, £2 times 6 is £12, and 20 pence times 6 is £1.20, so it's £13.20 altogether.
Yes. Now that wasn't too difficult, but sometimes the questions on the test paper wrap up the maths in a real-life problem which you have to solve. Try this question on the test paper.
Some children go camping. It costs £2.20 for each child to camp each night. They go for 6 nights. How much will each child have to pay for the 6 nights?
Have a go at it then.
Well, if one night costs £2.20 and they go for 6 nights, then the total cost will be £2.20 times 6. We've just done that, so it's £13.20.
That's right. You've solved the problem. There are 4 steps to solving a real-life maths problem. First, read the problem. Then, work out what maths you need to use to solve the problem, such as adding, subtracting, multiplying, or dividing. Next, work out the answer to the maths. And finally, go back to the question and answer the problem itself. Let's use these 4 steps to solve a problem in a real test question. First, read the problem.
Ah, here's a good one. There are 12 pencils in a box. A school buys 24 boxes. How many pencils does the school buy?
OK, for step 1, you've read the problem. Now, on to step 2, to work out what maths to use. The trick here is to look at the story the problem is telling you and to work out whether things are being added together, taken away from each other, multiplied together, or is one amount divided by another. Imagine in your head what's going on. On the test paper, they help you with pictures of what the question is about. Here is a drawing of one box of 12 pencils. And here's a drawing of a stack of 24 boxes of pencils, with 12 pencils in each box. So always look at any pictures in the question to help you work out what maths to use. Over to you.
One box has 12 pencils, and there are 24 boxes, so it's 12 times 24 pencils altogether.
Right, now you've worked out what maths to use, write it down in the space where it says, show your working.
One box, 12 pencils, 24 boxes, 12 times 24 pencils altogether.
So we've worked out what maths to use. It's multiplication. And the sum is total number of pencils equals 24 times 12. On to step 3 to work out the answer to the maths.
OK, I want 24 times 12. I know that 24 times 10 is 240, and 24 times 2 is 48. So 24 times 12 is those two added together. That's 288.
That's right. Now that just leaves the final step to answer the problem. With this question, that is the answer to the problem, 288 pencils. So write it in the box for 2 marks. As well as writing your answer in the small box, it's really important to write all your workings in the large box. Then, even if you get the final answer wrong, your workings might show that you were on the right track, and you might get 1 mark. That question needed 1 bit of maths to get the answer. We just multiplied the number of pencils in one box by the total number of boxes. Some problems in the test paper may need 2 bits of maths to solve them. Try this one.
OK, step 1, read the problem.
You got the idea.
A shop sells sheets of sticky labels. On each sheet there are 36 rows and 18 columns of labels. How many labels are there on 45 sheets?
OK, on to step 2.
I know, work out what maths to use.
Go on then. And does the picture in the question help you?
Well, there's a picture of the sheet of labels showing that there are 18 labels one way and 36 the other. So each sheet has 18 times 36 labels on it?
Yes, so start jotting things down in the workings box.
OK, one sheet has 18 multiplied by 36 labels on it.
Now that's one bit of maths, but I think this question needs more.
Oh, I see. They want to know how many labels there are on 45 sheets.
Yeah, imagine it in your head.
Well, if one sheet has 18 times 36 labels, then 45 sheets has 45 times that?
Yes, and show your workings out.
Then 45 sheets has 18 times 36 times 45 labels.
That's it. You've done step 2 and you've worked out what maths to use. It was 2 stages of multiplication. The total number of labels equals 45 times 18 times 36. Now, on to step 3.
To work out the answer to the math?
Exactly.
That looks a bit tricky to do in my head, so I could write it out.
Well, you could, but this question is on paper B, so it might be quicker to use the calculator. But don't forget to make an estimate first.
Well, if I make it 40 times 20 times 40, that's 4 2s are 8 times 4 is 32 with 3 zeros. That's 32,000.
Mm-hmm.
Now for the calculation. 45 times 18 times 36 equals 29,160. Well, that's not too far off my estimate.
So write it in the box for 2 marks. A lot of questions in the test are based on shopping and buying things. Now, shopping is something most of us are familiar with, but it can still be a bit tricky to work out the maths, particularly when there's money involved.
When you buy something and pay the right money, there's no maths to do. When you buy something and give a near amount, you use subtraction to get the right change. And when you buy 2 things, you add the 2 prices together and then use subtraction to get the right change.
Here's a shopping problem you can do in your head. Daffodils are 99p for a bunch. John buys 3 bunches of daffodils. How much does he pay altogether? Let's see how the maths team got on with this when they did their test.
I changed 99p into a pound, so it was £3, and then I remembered to take away 3p, which was £2.97.
So that's a money problem you could do in your head. This one's a bit more complicated.
Parveen buys 3 small bags of peanuts. She gives the shopkeeper £2 and gets 80 pence change. What is the cost in pence of 1 bag of peanuts? Well, that's all about shopping, but usually you know the price before you start.
Well, remember the second part of problem solving. Work out the maths in the story. The trick here is to think about what happens when you buy something and get some change, and then work backwards.
Well, if she paid £2 and got 80 pence change, then the peanuts must have cost £2, take away 80 pence. That's £1.20, so that's the answer.
But is it? Check what the question's asking.
Oh, it wants the price of one bag of peanuts. So I have to divide the £1.20 by 3. That's 40 pence.
Yes. And there were 2 bits of maths in that question, so it was really important to check exactly what the question was asking. Now, here's a question that's full of tricks. Step 1, read the problem.
Right. Nicola has £50. She buys 3 flower pots and a spade. How much money does she have left?
Step 2, work out what maths to use.
Well, I suppose I add together the cost of all the things she's buying and then take it away from 50?
That's right. So go on to step 3 and work out the answer to the maths.
But how do I know how much all the things cost?
Look at the picture in the question.
Oh, yes. The prices of all the things are labelled. A flower pot is £12.75 and a spade is £9.65.
So in this case, the picture in the question doesn't just help you imagine what's going on, it has part of the maths hidden in it.
Now this is in paper B, so I can use my calculator.
OK.
That's 3 flower pots times £12.75 each, plus a spade at £9.65 equals 47.9.
First trick to watch out for.
Oh yes, it's money. So 47.9 means £47.90. So the total cost of everything is £47.90.
Second trick to watch out for.
Oh yes, the question's asking how much money she has left from £50. That's £2.10.
So write it in the box for 2 marks. Now, what about the space for showing you're working? When you're using the calculator, you could think there isn't any working you can show. Well, in case you slipped up with your calculator and got the wrong answer, it's worth just jotting down the stages in your calculation so the marker can see you're on the right track, and you might get a mark. That's the end of our program on problem solving. So let's check what we've done. We looked at the 4 steps you need to go through to solve a problem. Read the problem, work out what maths to use, work out the answer to the maths, check back to the question to answer the problem. We looked at problems that need more than one calculation to solve, and problems involving money. If you want to, you can go over all this by winding the tape back and looking at bits of the program again. And there are also books and our interactive Revisewise website to help you prepare for your tests. So, we'll let you get on with your test, and you get on with your television revision.
The next program is about mental maths.
In this program, we're helping you with some of the things you might find tricky in your Key Stage 2 maths tests. Now, this time, it's mental maths.
That's doing maths in your head, isn't it?
That's right. Often, it's quicker to do some maths in your head than it is to write it down or use a calculator. But in the mental maths test, you don't have a choice.
What mental maths test?
Well, there are 2 written papers, and then there's a short mental maths test.
How do they test that?
Like this.
Here is the practice question to show you what to do. What is 6 6?
In the mental maths test, the questions are played from a tape.
What is 6 less than 25?
You work out the answers in your head and write them down on the paper.
Question 1. How many 20p pieces are there in £2?
That's completely different from the written tests. You've really got to concentrate with that tape going all the time.
That's right. And that's what we're going to help you with, to make sure that you make the most of what you know when you do your mental maths test. So, let's have a go. Before we start, you can't have any equipment to help you, so we'll get rid of the calculator, the angle measurer, the mirror, the tracing paper, and the ruler.
So I'm just left with my pencil?
Well, that's all you need. Oh, and your head to do the maths in.
But what am I going to write on?
This. It's the mental maths answer sheet, which has boxes on it for you to write the answers in. So, we're ready to start.
Key Stage 2 Mental Arithmetic Levels 3 to 5 test. You will have 5 seconds to work...
And remember, no talking during the mental maths test.
Question 1. How many 20p pieces are there in £2?
That's not too bad. £2 is 200p. So 20p goes into that 10 times.
Question 2.
Hang on a minute. I've only just done the first question.
From
That's right.
120.
For the first few questions, you have 5 seconds to answer each one. After that, there are some questions that give you 10 seconds to answer them, and then a few at the end that give you 15 seconds to answer them. Remember, once the tape has started, your teacher can't stop it, so it's important to keep up. If you get a question you can't answer in the time, forget it. Listen to the next question. Otherwise, you might miss a question that you can answer. It's also a good idea, if you can't answer a question, to put a big cross in the box. That'll stop you putting the answer to the next question in the wrong box.
How many millilitres are there in 2.5 litres?
OK, 2.5 litres is 2,500 millilitres. That's 2,500 millilitres.
How would 4:15 in the afternoon...
Hey, can we stop a minute? What's that 2.5 litres there for?
It was in the question. Sometimes important numbers from the question are printed on the answer sheet to help you, so you don't have to rely on remembering everything from the tape.
And the questions are all mixed up. We've had one about money and one about capacity.
That's right, they are mixed up. But they'll all be questions about the maths that you've done at school.
Put a ring around the fraction on your sheet.
That's a question about fractions.
A bus is due to arrive at 9:50. It is 25 minutes late.
That one's about clock times.
Subtract 40 from 120.
And that one's about subtraction. We can't go over all the different questions you could get in your mental maths test, but we can go through some of the things you can practice. When you're faced with a mental maths problem, first, work out what maths you need to do. Is it addition, subtraction, multiplication, or division? Look out for these words. First, for addition.
Addition means how many altogether.
It also means increase.
It also means plus.
It also means total. It also means sum. It also means more than.
These are the words for subtraction.
Subtract means take away.
It also means decrease. It also means difference between. It also means minus.
It also means less than.
It also means count back.
Multiplication words.
Multiply is the same as times. It also means product.
It also means lots of.
It also means groups of.
It also means sets of.
And it also means repeated addition.
And division words.
Division means share equally.
It also means group equally.
It also means divide by. It also means repeated subtraction.
If you know these words, you'll have no trouble spotting what the maths is you need to do. But how do you actually do it? To start with, know your number facts. Number facts are things you either know or can remember, so you don't have to work them out each time. One set of number facts that's always useful is our times tables. Over to the maths team.
1 times 4 is 4, 2 times 4 is 8,
3 times 5 is 15, 4 times 5 is 20.
6 times 6 is 36.
7 times 8 is 56.
9 times 9 is 81, and 10 times 9 is 90.
Once you're sure about your tables, you can use them to help with any multiplication problem. Have a look at this one. What's 40 times 70? Well, we know from our times tables that 4 times 7 is 28. 4 times 70 is going to be 10 times bigger. So that's 280. 40 times 70 is going to be another 10 times bigger. That's 2,800. The trick is to multiply the significant digits and then make sure you get the place value right by having the same number of zeros in your answer. Don't forget, addition facts are useful too, like all the pairs of numbers that add up to 10, or all the pairs of numbers that add up to 11, and all the pairs of numbers that add up to 12, and so on. Knowing these will help you do addition and subtraction really quickly. But what about division? Over to the maths team again.
A number is divisible by 2 if the last digit is even. A number is divisible by 3 if the sum of all the digits is divisible by 3.
A number is divisible by 5 when the last digit is 0 or 5.
A number is divisible by 9 if the sum of all the digits is divisible by 9.
A number is divisible by 10 if it ends in a naught.
Let's look at 59 plus 43. See how the maths team changed this sum into something easier on the way to getting the right answer.
To find the answer to 59 at 43, I'd turn the 59 to a 60, then at the end take away 1, and the answer would be 102.
With any number ending in 9, you can add 1 to make the sum easier. With a number ending in 8, add 2 to make the sum easier. And with a number ending in 7, add 3 to make the sum easier.
To find the answer to 43 at 59, I'd add 40 at 50, then 3 at 9, and then add the totals together, which will make 102.
What about subtraction? Try 54 minus 37.
To work out the answer for 54, subtract 37. I rounded the 37 to 40 and took it away, which was 14. Then I added on the 3, which gave the answer 17.
What about multiplication? Try 58 times 6.
This is how I would work out 58 times 6. I do 50 times 6 is 300, then 8 times 6 is 48, and add it together, which would equal 348.
Another tip when you're faced with a problem is to build on what you know. What's 30% of £5?
To find 30% of £5, I would divide by 10 to find 10%, and then times it by 3, which would make 30%. Altogether, it would become £1.50.
Remember that percentages, fractions and decimals are all related.
50% is also equivalent to a half.
25% is equivalent to 1/4.
75% is equivalent to 3/4.
10% is equivalent to 1/10.
20% is equivalent to 2/10.
And to change a percentage into a decimal, divide by 100. So 50% is the same as 0.5. 25% is the same as 0.25. 75% is the same as 0.75. 10% is the same as 0.1. And 20% is the same as 0.2. Try this.
Put a ring around the fraction on your sheet, which is equivalent to 40%.
I know that 10% is 1/10, so 40% is 4/10.
Not all the questions on the mental maths paper are about numbers. Try this one. You've got 10 seconds.
Imagine a triangular prism. How many faces does it have?
Well, there are 2 triangular faces at each end, and 1, 2, 3 sides, so that's 5 altogether.
That's the end of our programme on mental maths. So, what did we do? We saw how in the mental maths test you answer questions played to you on a tape. Questions that cover all the different kinds of maths you've done at school. We explained how it helps you to know the different words that describe addition, subtraction, multiplication and division. And how using number facts, like your times tables, will make it quicker to work out the answers. We saw how breaking problems down and building on what you know makes them easier to do. If you want to, you can go over all this by winding the tape back and looking at bits of the programme again. And there are also books and our interactive Revisewise website to help you prepare for your tests. So, we'll let you get on with your test, and you get on with your television revision.